Hi everyone, welcome to this one more video for this series we are having, that is machine learning fundamentals, and this is episode 6B. We were having episode 6 where we talked about unsupervised learning, and we discussed, in fact, we deep dived into unsupervised and what is the situation in which we can use it, what kind of data we'll be having in hand on which unsupervised learning will be suitable. And then we discussed about K-means and PCA, principal component analysis. So that these two things, we compared as well, and then we talked about what are the differences in these two. So I shall be starting from the same point. This 6B episode is actually for the practical deployment of both of these. And without wasting much of time, I will do one thing. I'll first of all go and start from the same point I left, and then talking a little bit about K-means, will be directly going to afterwards. We'll be directly going to VS Code editor, and we'll be just starting to write a Python program, and with that I'll be giving you explanation as well. So let us just start. This is in fact where we had left example 1, which was customer segmentation with K-means. So K-means we had discussed, but example, no, I had just given that customer segmentation can be done with this. But this is the example where we can just show how we can implement K-means on customer segmentation problem. So what we are having actually is we are having a data in which we might be having annual income in thousands, $1,000, 1,000 reals or whatever. So spending score from 0 to 100. So it can be score how a particular customer is spending. So it will be a score from 0 to 100 based on which customer can be segregated into a particular group. And then uh, no columns are there that are saying, for example, budget, which is some categorization, which we can say budget, regular, or premium shopper. So we don't have any categorization done for the customer. So that is what we will be looking forward for by this K-means. Uh, why K-means fits this problem, we have discussed it earlier as well. The algorithm looks for natural groups in fact in the feature space. So the features we are having are the income and this spending score. So from there we can just look for the grouping, natural grouping of the customers, and the output is a cluster ID for every customer and the centroid for every segment. So definitely that we'll be having for every customer this output will be having a cluster ID to which a particular customer will be in fact belonging. We can divide it into multiple custom clusters, and those also I'll be showing you with the code that where that choice is given when we are deploying this K-means. That K is actually a cluster, so you'll understand that. So that value of K will be telling the model that how many clusters or groupings we need to do. And this is useful when the business does not already know the segment labels. So for example, we are having a customer base, the information about customers, but that particular business, they don't know the segment labels which are missing, and they want to categorize their customers. So this is what can be done. So going forward, we are having, in fact, this is the VS Code where I have opened this file already here, so you can just see this. On this one, let me just go and put in this code one by one, and in fact, I'll be writing it down. So let me just start. One moment. Okay, let me just start writing. So first of all, the skeleton which we are having available, which is common for all of those, maybe some certain changes. So first of all, we'll be doing importing of various. So first of all, we'll be having NumPy. So I'll import NumPy as NP. We had been doing it for different programs already. and then I'll be having import matplotlib. So this is matplotlib. I will import .pyplot as PLT. So this we had been doing from sklearn. We will be just taking a different thing. So we'll say sklearn.cluster import KMeans. So we are importing KMeans from there, and then now I will be having an initialization of data. So what is my data? So my data is data equals to np dot, I am initializing it to an array. Okay, now this array consists of what? It consists of the following. So what is array consisting of? So first thing, it will be having, these are the values which can be there. I can even just copy these values from the file. It will be easier for me to write, or else I can just type them. 25 comma 24. Okay, then I will be having one more, and then I will take 28. These are actually inputs which are which we are giving with the array, and these inputs are what? They will be giving us the income and the in fact the expenditure, or the what kind of expenditure a particular person is doing, which we discussed already. We are having two parameters in this one. One is spending score, which will be from 0 to 100. So we are giving spending score. First of all, annual income we are giving, and then the second thing what we are giving is the spending score. So this here we are giving two parameters there. So first of all the income, and then the spending capacity, or the spending score a particular customer is having. So next this we have put 3 values. Now fourth one, so 31 and 27, and then I can have one more. I will be having 43 and 48. So I can just put it like this, and then I am having one more, which is 46. So these will be, I believe, 56, and then I have one more, which is 50 and 53, and then I'm having in fact 54 and 60. So 54 comma 60. So these are the things which we are giving as an input to this. This is our data. This can be completely taken from, these are the basic examples shown here, but normally the data is taken from the file. It can be a file which can be a CSV file, which can be given as an input. So that is normally happens, but these are the basic examples which I want to clarify first of all, so that the initial concepts are known to the students. They are able to comprehend from there, and then it is not a big deal to capture the data from the CSV file as well. So we can have similar kind of a data, or some other kind of data, probably huge in size as well, that can be captured. So but here it becomes very convenient if we are doing it like this, where we are putting. So I hope that I have inputted this data in a right way. So I feel that is the case. Okay, anyways, it's not going to make much of a difference if, for example, somewhere we have for example given any kind of a data inside, but the thing is, it should be inputted in a proper manner, so that that error does not happen. So I think this is fine now, and then now we have to, when we have given the data, we remember that there is from the previous programs, that we are having a specific if you just see specific main this pattern which is there, and then that pattern or skeleton which we are repeating in almost all the programs. Now with that we have to apply the model first. So model, now initialization of import of various libraries happened, and then in fact the initialization data we have explained, and now we're having the model. So model equals KMeans. So we are saying it equals KMeans. So we are using now this KMeans and underscore cluster. So it is giving this cluster equals 3. So we are now initializing here that how many groups we want to make. So we are giving 3. So it can be more depending upon what. And the random state, we have explained it already, I think, multiple times, where we were in the supervised learning as well. 42 will be taking a data which will be having a consistent consistent these results generated, otherwise it can vary. And when we are saying init is equal to 10, it will be running the algorithm 10 times and it will see the best possibility, and then it will be taking. So that is what this says, and this is the model we have just put in place. Now I am saying, now I am applying the model to the to this data which we are having. The labels equals to model.fit. So in the similar manner we have done it. Little bit difference will be there in the syntax when it comes to data. So labels is equal to model fit predict dot data. That is data which we have initialized up there. So it will be applying this model now on there. And centroids. So we are having centroids equals model dot cluster centers. So cluster centers, and this will be, we'll just put next. Now it is the time to print the cluster labels. And it will be putting them as labels. So we are going to print the values now. So this is how it's going to happen. And then we can, it is just completely additional, that if we would like to have graph plotted, so then we can plot a graph. Otherwise that is not required. We can just say plt scatter, like we did in the previous examples as well. So we are putting data, and then we are giving that first of all one axis and another axis, and we are putting that in that particular way. So this is one axis which will be putting the data, okay, and then data again. So we'll say data, and then it will be one, okay, and then it should be C is equal to labels, and S equals 80. Then we'll be plotting again scatter centroids now. So this is data, these are centroids, and now we'll be having, in fact, same thing again, and certainly centroids. So we are having data, now we are having centroids. Centroids again will be having colon and comma 1. So this is very simple, and the marker is going to be X. Marker is equal to X. So this, and then S equals 220. Okay, this is then we can just plt.title, we can just give a title to this, and the title we can just have, for example, KMeans customer segment, for example, or segments, and then we can again have the X label like we did earlier. So this is, all of this is optional. There is nothing, this has got nothing to do with the machine learning algorithm itself. So this is just for the sake of, okay, I think I have just done some mistake out here. So plt.xlabel is equal to annual. So this is annual income, and then I think this one has not been closed properly, that's why this is giving an error. Okay, now it's fine. So this is extra, and then plt dot y label should be the spending score. So spending score, which is there, and then we are having plt dot show, with which will be showing us the graph, otherwise that will not happen. So this is, all of this is an optional. Actually the program is up till here, where it will be, you know, doing this, applying this k-means on this, and we will see the output of this program now. So let us just go ahead and say run this. We'll be using Python debugger for this one, and if you just see, okay, we are getting line 15, some error is there. So let us see what the error is. I think it's here in this one. So that is, it's a very easy thing. I think I have just put a semicolon instead of semicolon. I have put a colon. So that error is there. Where, okay, this is the one. I think this is the only one which is there. I don't think anywhere else there is any error. So let us just see and run it again and see. Okay, I think it should be going now. And here it is. So cluster table, it is giving us, so if you just see, it has reduced, k-means is actually dividing. We told it that you divide this data into 3 groups. So what we have given as a data, if you just see, these 3 are given as a data. These are given as a data. So what is this? So first thing what we are inputting is the income of a particular customer, and the score of spending score, which is there. So based on these 2 parameters, which are given in an array, so 2D, it is reducing it to one thing, and for that it is with this program which we plotted. So this is the plot it is giving actually. So this is the one which it is giving. So you are giving, one side spending score, another side is annual income which you have given. Then you are putting the title as well, and you are putting the legends. Okay, legends are not there actually. Okay, you are putting the title X label and Y label you are putting. So this is X label and Y label. Annual income is X label, and spending score here is Y label. And it is plotting this graph on this one on the basis of this. And then it is saying that we are having these markers. If you just see, we are having these, and these are 3 different categories of the customers, where they are having maybe low income. I think these 3 categories which are there, we can just see that it is a low income and low expenditure category 1 of a customer, and then there is a medium income and medium expenditure category, and there is high income and high expenditure category which is coming here. There can be multiple categories as well. So this is the simplest way of to understand k-means, the simplest example in an unsupervised learning model to understand the k-means. And coming to this, next example here is, I'll be going forward with the next one, which is in fact, so this is k-means. We finish this, and then the interpretation, if you just see of this one which is done, customers close to one another have similar income and spending behavior. So that is for this particular example. It can be with the data, depending upon the data, it can be entirely different. Each color represents one cluster, and it is returned by the model. Large X markets are centroids, so definitely these are the centroids. The average location of each segment, so that is the average location. So centroids, don't get confused with that, it is the average location. The groups can be used for targeted marketing, pricing, or campaign designs. So when we are saying centroids, so these are actually the average locations for every segment. For example, a low income segment will be falling on a particular, so for that there is a centroid, so average for that. In the same manner, the medium income sector or the group will be falling on a particular centroid, so there will be a centroid for that, where it will be an average location for those. So it is so this is where these are shown, and a similar kind of a diagram I would say exactly the same diagram we got on similar diagram we got on our output of the program. Now for the PCA, if we see for the PCA, so principal component analysis. We just have original features are there, for example, which is price of a battery life, a weight, and camera quality. I think these are the features which are there. uh, and then these features, uh, four dimensions are difficult to visualize directly, so definitely these are very difficult to visualize, that is right. This is actually, these are gadget features. PCA rotates the space and keeps the direction with strongest variation. The result is a compact 2D view that preserves most of the information. So we are having, so instead of this multiple features, we are having a 2D view, which is in fact giving us a clearer picture. So principal component 1 and principal component 2. I think there are for this particular example there are three separate you know there are three separate features which are reduced to two. So it's a 3D which is reduced to 2D. And we can just in fact I will just the program which is here written, which is on your screen now. It is it will be giving generating an output. We can just see that it will be a graph output only, but it will not be giving actually the output which is so if you just see this one, it will be a graph output. It will not be generating us the so I think this is the one which we had finished now. I'm having this particular program which is for this principal component analysis. If you just see this one, this program will generate. So we can just go ahead instead of writing, and it will be resulting in a lot of time. So I have just put in this program here. I can just again. So this is the same skeleton we are having. Instead of KMeans, now we are importing PCA, and we are importing standard scalar. So if you just see, then we are initializing here. Instead of data, we are saying products. That is fine. Anyways, this is also the same thing. So we are having, these are the products: alpha, beta, gamma, delta, epsilon, zeta. And then we are initializing X to an array which is giving these so 799, 18, and 170. So three things are there which are given, and those three things are discussed in fact in the slide as well. So those three things which were there which are for this, so we are having the parameters for this one. It is for example, original features which are there. So they are price, battery life, or it can be weight and the quality. I think here we are having the products, these six products, they are having three features which are given. So this can be reduced to a 2D. So I think this is in fact the 3D that can be reduced to a 2D. So these are the inputs for this. So we are giving these three values, each one of them. There are six. So there are total six, inputs to this one. And then we are just doing this X scaled. Uh, I think this particular thing here is okay. That's fine. So X underscore scaled is called a standard scalar. So we are now actually training the model fit underscore transform. So we are training the model, and PCA is equal to PCA and underscore components is equal to 2. Now we are putting it that we want two features. Here it will be n components, means how many we want to reduce to how many feature sets. For example, it is having 5, 10, 4, 6 feature sets. Then it will be calculating that which particular feature is in fact which particular feature is in fact worthy, and which will be having more weightage as far as the information is concerned. So we can just say that a particular feature might be giving us some 80% of information. We might be having a data which is having one column which is providing us 80% information. One more column is there which is providing 15%. And there are four more columns which are providing just 5% information altogether. What we can do, we can just say with two features only, reduce that data to two features, we are getting anyways 95% of the information. So what we are actually looking with PCA, we are reducing the number of features but retaining the information that we are getting from the data. That is the main motive behind this. And then with this we are components equal to PCA.fit transform x scale. Now we are saying components now which are equal to, we are saying that you put it fit and transform, and then those components, now we are applying this to PCA to these number of components which we want, and then explained variance, PCA.explained underscore variance underscore ratio. So it will be printing the variance, and then this plotting of graph is something optional again, which I told. But I'll be showing the output of this program, but I have just modified it a little bit so that it delivers a better result. If you just see this one, it is putting the variance out. Now it is something very important to understand that what is this variance, explained variance. So it is reducing first of all these values to 2D. From 3D it is getting reduced to 2D, and then it is in fact these points are there which are in fact reducing it to two components only. So we are having all the different data which are there, we can say products which are there, and they were having three, for example, three features each one of them, but they have been reduced to two features, which is principal component 1 and principal component 2. So they have been reduced to this. And then if you just see now the little bit of, because this is not providing us that visual or the output that we would have liked to so I would just say that this program which I have modified, so this is looking better because it is actually giving us the output. I will just explain to you. So it is giving us the output. So first of all, it is printing what we are having. So let us run this. I have modified this here. So some modification I have made. So certain prints I have given the printed first of the original data. I have printed first that, and then after applying the scalar, I have printed the standard data, and then after that standard shape, and then applied the PCA, and then the data has converted from reduced from 3D to 2D, and then PCA reduced data 2D, and then it is in fact printing those components which are there in the 2D, and then it is calculating variance of that, and then after that it's giving interpretation that the original data was having three features, or these many features. Now the new data is having this feature, and then it is saying that PCA reduced the data from 3D to 2D, and that is also printed out, and then after that it is giving the graph which we were having in the previous program as well. So when we are running this, it will be giving us a better kind of an idea that what exactly happens. So if you just see this, I'll be showing the graph as well which has been generated. So if we see this particular thing, so let me just take this results little up, if I'll be able to do that. So let me just take this little, okay, sorry, let me just take this little up from here. So if you just see this, this is our output terminal. So what it is giving is, first of all, it's giving the original data which is already here. So we have given the same data here. So if you just see 799 18, so it's outputting the same data. And then there is a standardized data on which this application happens. So how that happens, it will be calculating mean, it will be calculating the standard deviation, and then the value of this will be calculated for each of these. And then at the end, it is reducing this one, based on the significance of a particular feature. It is reducing that 3D to 2D. So it is reducing this 3D to 2D based on the significance, and PCA reduces data to 2D, and this is the 2D, and reduced shape will be 6:2. Sorry. 6 is actually the categories, number of categories, and 2 will be the features. And then the variance with ratio, which is there, that it is calculating. Variance ratio will be telling that, one feature, it is having how much of significance as far as the data is concerned, that how much of data it contains. So that is this one. First is having 96% of the significance, and second, this one is having just 23%. No, sorry, 2.3%. So a very less, significance of the second as well. Now we have told it to give us the two clusters, or two of these components. So it is giving us two components. Otherwise, even if we are reducing it to one, it is still having a significance of 96%. So the interpretation original data had three features. After PCA, principal component analysis, data has two principal components, and so the PCA reduced the data from 3D to 2D. And if you can just see, the graph is all same which we had in the previous program. So this is what is principal component analysis, and when both of these are combined, when we combine, in certain problem which will be coming up, maybe possibly in the next episode, when we are having, or it might be at the end together. Maybe first of all we'll be just going ahead with concluding this unsupervised, and then after unsupervised, we will be taking reinforcement learning, and then we'll be having complicated programs together done by the end of the series. That means, this series, it might be having some 15 to 20 different videos. So maybe from 15 or 12 onwards, we'll be taking some complex problems in all supervised, unsupervised, and reinforcement learning to conclude these fundamentals of machine learning. I hope that this video would have been very beneficial in understanding a practical implementation of unsupervised by using KMeans and PCA, principal component analysis, and how the data can be reduced, and on what kind of data we can use actually unsupervised, and what is actually the motto behind this. All of that is clear. I will conclude this particular video here, and this will be video 6, episode 6B. And I hope that you would have been benefited by this. Do provide your valuable inputs to us, that inputs by feedback, and subscribing to the channel if you are feeling that this is beneficial to you. And in case you feel that there is some need for enhancement, change, you can give your valuable feedback. You can be very critical, there is no problem in that. That will be taken very positively, and we will try to just embed those changes in the upcoming videos and a series that we are planning to, in fact, put on our this YouTube channel. So thank you so much once again for watching this, and do subscribe and continue watching this very interesting series which is on machine learning fundamentals. And until then, see you. Thank you.